Okay, this is the P2 paper from October 2022. This is question number 6, and it's a chapter 8 integration question. There's going to be the first part, which is the trapezium rule, and the second part, which will start off by working out the area under a curve. And then we'll go on and do an estimate for the percentage. Let's look at the first part though. The first part says we've got a table of values here for y equals fx. We don't know what the function is. That's the whole point of trapezium rule questions. But they have given me, the values of x that lead to values of y. So what we can do with that then is decide that we've got y0, y1, y2, y3, and y4. So those are the values that I'm going to use for the trapezium rule. If I want to work out an estimate part A for the integral between 0 and 2 of fx dx, then I can use the trapezium rule, which states it's d over 2. Because of the number of y values I've got, it's y0 plus y4, and then 2 lots of y1 plus y2 plus y3. So we're just simply going to be substituting in there. What's d going to be? Let's go back and look at the difference each time there. The difference each time there is 0.5. So I'm going to have 0.5 divided by 2. And then these values are all on the table. So 3, 1.92, 2 lots of 2.6833 plus 2.4 plus 2.1466. That's more than enough method marks, and also it means I'm most likely to not make a mistake if I have all that information written down. If I work that out, stick that into the calculator, it works out to be 4.845, and going back and just checking, it says give your answer to 3 decimal places. Now, this second part's quite interesting. We just need to look at it. It's an unusual one. And it says the region R shown in the figure, yeah, I can see that, is bounded by the curve C1, which we've already got. So what we've just found is we've found the area under C1 there. We've got that already. That's my approximation. And what they now want us to do is to try and work out R. Well, R is going to be that shaded area that I've just done, subtract the area under the curve there. Now, the area under the curve I can find by using integration. So the area under the curve is given by 2 minus a quarter x squared. I'm going to find the area, so part B, the area under C2 is simply going to be the integral between 2 and 0 of that curve, which is 2 minus a quarter x squared dx. So we can do that. That's nice and simple. The integral of 2 is 2x, and the integral of minus a quarter x squared is add 1 onto the power. Divide by the new power means dividing by 3. The quarter's already there, so that becomes 2x minus x cubed over 12, all between 2 and 0. And then again, just stick the values in to work that out. That's going to be 2 lots of 2 minus 2 cubed over 12 minus. Now, I trained myself to do this. It doesn't make any difference with this particular one. I'm going to have 0 minus 0 in that second bracket. But I always just quickly do it, just in case. Sometimes sticking a value of 0 doesn't always give us a value of 0. Working that out, that works out to be equal to 10 over 3. And now I need to absolutely go back and check what I wanted to do. So we don't just want to find R. I can find the area R, excuse me, as being the difference between those two. But it says calculate an estimate for the percentage of the logo which is shaded. So what I want is that difference there, so let's just say what we're doing, the percentage shaded will be the difference between 4.845 minus 10 over 3, but as a percentage then I want that out of the total area, and the total area is just 3 times 2 here. So it's that difference over 6 multiplied by 100, because I want it as a percentage, so that's going to work out to be apparently 25.2%. And what did they say? Oh, they didn't say, so okay, I've just done it to 1 decimal place there, as we're actually going through and working out that answer. Yeah, a real classic question for making sure you've actually answered the question that they've said there, okay? Lots of relatively straightforward stuff, but we then got to make sure that we get all 4 marks here by concentrating on answering the actual question set. Okay, hopefully that makes sense.